Hey there, folks. I'm your host, Mark DiCarlo, and welcome back to Studs. This is the game show where we give one lucky lady her choice of eligible batch. April Fool. Welcome back to Deliver More, the industrial coatings talk show brought to you by the exceptional team here at Intech Services. I'm thrilled because I am joined by two gentlemen today, Chris Lorde, Mike Patterson. It's good to see you guys.
Hello. Am I bald head guy number 1 or 2?
It's all about the flex. We're going to get to that later and see how we do. It's been a while. You guys were both in the finals of the March Madness competition.
We were.
Mike, you're the champ. You squared off against the savvy veteran Wolf. That was quite the matchup this year.
It was tough. I came out on top. I just returned from a victory tour.
Did you really?
Yeah, it was one hell of a celebration. Sorry, Wolf, but we really took care of business. The trophy's a little dented and banged up like the Stanley Cup sometimes is.
Yeah.
But it's back in order.
I saw the TikToks. Mike had the trophy up at Dacres. Everybody was touching it. It was pretty cool. Guys, they say April showers bring the May flowers, but as we're talking stormy weather, we're talking the month of April. This is a topic this month that we haven't broached before on Deliver More, and that's really interesting to me. So this month's topic is dielectric strength. Mike, let's start right off. You got to educate me, my man. What's dielectric strength?
All right. Well, this is definitely a nice technical topic to kick off the spring. Dielectric strength is really the ability for a material to withstand an electric current.
Okay.
So in the case of Teflon, and in our coatings world, Teflon's a natural insulator, which is great because that means it naturally provides insulative properties to the base metal that it's applied over. Mm-hmm. So for those of you that are doing powder coating, that's why you can only apply maybe 2 mils of coating electrostatically before it starts building enough to insulate, therefore negating any electrostatic ability for application. So that said, dielectric strength is how much current the coating can withstand before it fails or allows the current to transfer through the coating material, in this case, to hit the base metal, which in that case would cause a spark or some sort of failure in that environment. So it's a very, very important property of Teflon.
Yeah.
One that mostly we really don't talk about. I mean, it's something that's kind of there. It's like, people know it's insulative.
Yeah.
But there's certain applications that very heavily rely on that capability. But it's one of those kind of natural things that people, I think, take for granted in a lot of situations. So it's nice to be able to talk about it today and educate people about what dielectric strength is and why it's important and which of our coatings really excel in that world.
Absolutely. And I want to get to those coatings in a bit, but it is important that we're talking about it. But I feel this is kind of strange. We've been doing this show for a couple years now. It's the first time this has come up, Wolf. Yep. And so I wanted you to talk about the industries where this is, important, what industries rely on this. But historically, this hasn't come up. Is this something you've been hearing a lot more about recently?
Well, it's something that is on it's one of the performance characteristics that come with Teflon, but it just wasn't talked about much. My first 12 years being here, it's something that, I think people knew about and you were inherently getting, but, in this day and age, it's all about safety, and that's really what it's about. And in a traditional type of, power generation, aerospace, things like that, Teflon coatings have been used for years and years and years, and you kind of got that quality. And some of those specs are really old and have been around for a long time, so you weren't really talking about it very much. And then in the past year, I go to the ACT show in California, and then I go to the EV battery show in Michigan, and I came back to Mike, and I'm like, there's a total play here for Teflon with all this new, EV electrification of vehicles, things like that. One of the big problems they have with those vehicles is runaway, which is, fire. There isn't electrical protection or insulation, or they're just starting to get into where they're protecting from that runaway situation where vehicles catch fire. That was one of the biggest, I think hazards that came with EVs, and it's not going to change. And we're going down this path, and you have these new markets, and the power grid and houses are going to have to charge these vehicles and things like that. So that safety requirement continues. It's actually probably even greater now than ever.
I think so, yeah.
So that's why I told Mike, I was like, we've heard more about dielectric strength in the last year than I did in the first 12 years I was here.
Remarkable.
But, like in the chemical industry, a lot of times chemical type of performance qualities, they need thick films, they need chemical protection, and you got that dielectric with it.
Yeah.
So it wasn't really talked about very much, but they needed it, and that may have been something that was kind of ancillary, but because they were doing, coatings that were 15 mils or 20 mils, they were getting that dielectric.
Right.
So it wasn't really something we were talking about very much.
Well, in a good example, somebody would coat a vessel that they're going to say store solvent in. So they need it for the chemical resistance of the solvent, but they also want to make sure the coating itself or the vessel itself doesn't spark. So that Teflon is providing that spark resistance because it's insulative. So they're kind of getting the best of both worlds without really asking for it.
Yep.
So we've known it's been used in these industries, like Chris said, chemical for decades. But we never really had an appreciation for what it was bringing to the table until we started getting a ton more inquiries about it.
Yep. Gotcha. So we have military, we have aerospace, chemical processing, and obviously the power industry.
Sure.
And that's the other part. There's military, aerospace. That's all part of the electronics realm. And what that's really, a lot of things that we see is really a need to help prevent electrical interference. So it's not a chemical atmosphere. It's like, hey, it's a harsh environment that might be high altitude. It might be salty. Some stuff might be underwater. It might be in space.
Yeah.
But at the same time, they want to make sure there's not circuit boards jumping and arcing and things like that. Same with the power grid. All the power things that are going on, like Chris referenced, transformers and capacitors and all these things that are happening out there to move power around all require insulation to keep those operating efficiently without having like electrical bleed where maybe the voltage is being diluted because it's not insulative enough. So it's vast, and the more we learn about it, the more we really rely on those properties of Teflon to continue to provide that high-end performance that people require.
High-end performance and, like you said, keeping people safe. It's topical right here with the storms and the tornadoes we're seeing all over the country.
That's one of the requirements, Nick, is the harsh environments, is the low temperatures versus the high temperatures and things like that. That Teflon pretty much naturally withstands. So it's such a great play when you're going through that situation and looking for a recommendation.
Very cool, very cool. So speaking of recommendations, so I've been to the warehouse. I've seen the products that we carry. This is what we do now. Tell me a little bit about the products that are I guess, best for providing dielectric strength.
Sure. So, the four families is what we're really referring to. And the best
that's the Corleones.
Absolutely.
That's the five families. Okay.
Absolutely. But PFA and ETFE are by far the best. And again, we have that information if anybody needs it or needs a refresher around that. But you're looking at like 2,000 volts per mil that you would get out of a PFA or ETFE. And again, these are just straight numbers. There's other factors that factor in. FEP's around 1,1500, and then PTFE is the lowest. It's around 450, 500. And the reason for that is because PTFE is naturally porous. It doesn't really provide that. It doesn't melt flow when you cure it, so it's not necessarily used as a barrier as much as the other ones are. Mm-hmm. But then you have the other piece of the equation. You always have a DFT need. So you got to have a thick film, or you want to have a thick film, but you also want to be in a situation where you're coating in multiple coats. Yep. Because, we never want anybody to say like, I could do 4 mils of this coating in one shot, and that's all this guy wants, and it's less processing for me. There's really not much of a guarantee there that you've applied a film that's pinhole free.
Okay.
And hopefully you're testing, and we'll talk about that in a minute, but it's really better to say like, I did 2 coats at 2 mils at a time versus just trying to do one shot of 4, because that will be, you'll have much, much better results if you do it that way.
Okay. Well, let's say like I have a coating. Okay. And how do I know if that coating has a decent dielectric strength? Are there feats of strength we can do? Do I do like Dusty Rhodes in the ring and do the test of strength, or what do we do?
There's a couple ways to test, Nick, and I think one rule of thumb I've heard. This is not really a formal rule, but I think what a lot of people tell me they do is if there's a specification that's requiring just say 10,000 volts of dielectric strength. They'll apply enough coating as if it was 20,000. So like 2x what the requirement is, just to give yourself that margin of error and extra safety precautions. Because if it's important, then you want to make sure you're going above and beyond. So that's kind of number one, is especially as it relates to Chris was saying around film thickness, is to really look at the requirement on the specification and go above that, because you don't want to just barely get by when something's related to safety. So that's number one. Number two, there's really two ways to test for dielectric strength, and one is like a high voltage method, and then there's a low voltage method. And which to use is really dependent on how thick your coating is. So a lot of people use the high voltage method, also called a high pot. Some people have seen it's more of like the higher above, say, 20 mils, so say 40,000 volts if you need something of that magnitude, which is out there. I mean, we've seen a lot of people test for that. And so that's where, and Frank's got some video he'll cue up here from Alchemeter, who makes both sets of equipment. And these are both ASTM type methodologies. So it's not just people pulling the methods and doing it, out of the air, out of the thin air. There's a technique to follow this to make sure your results are consistent and valid. But anyway, the high voltage method will test, 20 mils and above. It's great for that. The only problem is because it is high voltage, you do run the risk of it being a destructive test. So if you're running right up to the edge of where you're supposed to be, and it's not a perfect coating, you might cook your coating.
Yeah, I'd imagine.
Yeah, now you're at a spot where you probably have a big problem, and you might be stripping that coating off. So we see this happen sometimes in terms of doing the high voltage method. I've never seen anybody have to strip it, luckily. But that's why you do 2x the amount of coating. So you don't have to do that. What we see more often is called the low voltage method is more of what we see as like the wet sponge method. And so what this is also an Alchemeter type scenario, where it's a wet sponge that you wipe over the coated surface, and if there's any sort of void, that water will reach the metal substrate, and it will come back with a little jump on your voltage meter. So it's non-destructive. It just points out where there's areas of void given the amount of electric current you're running through. And this is usually about 20,000 volts and below. I see it commonly used at 5 or 10,000 volts. In a case like Chris said, that's 2,000 volts per mil for PFA. So that's a pretty thin coating. You're talking like 4 mils was going to, 4 or 5 mils will withstand that. So even if you had like 8 mils on there, you're going to be fine for that, which is a no-brainer for PFA. 8-10 mils is easy. But so this, the wet sponge is something we see a lot of. Wet sponge is also used extensively in the chemical industry, because just as it will detect electrical voids, that information will also tell you that it could perhaps allow chemical voids to go through. So if you have a chemical tank and you want to see if there's any voids in your 10 mil coating, that wet sponge test will tell you whether you have a pinhole that somehow made it through your process. So it's a really, really useful test that I think virtually every coder around the country that's in these industries has that equipment on hand and can perform that for their customers.
Okay. Well, I know it's always informative, the talks here, but the technical talks that we get to have, I always learned, it's always educational as well. But I think it was cool this month, because you were telling me this is something you guys are talking about more and more. Yeah. It's out there in the ether. Let's bring it in front of the microphones and talk a little bit more, Chris.
Yeah. Again, I can't talk enough about it at this point, because it is, we are here to educate, and we always wonder, like, what do people not know about the Teflon coatings? What are they not hearing a lot about? And this has been one of them over the last, like I said, 10, 12 years. We haven't really talked about dielectric all that much. And now it's starting to come up, and, the guys that work for, with Mike and I, they're, not as well versed maybe at dielectric. So we've had to have, some refresher courses there to be like, hey, this is one of our performance qualities. We do have coatings that are really good in these situations. And just kind of go through the calculation and how you do that and things like that. So it's exciting.
Well, it's like anything, Nick. We always say that the coating selection part of it is a balance of the properties. So as we're seeing these different environments come up, say for battery production for electric vehicles, where they need high degrees of chemical resistance but also dielectric, it makes us ask questions like, so Ruby Red as an example, PFA is really great, but Ruby Red has a lot of filler in it that make it really outstanding for permeation resistance and chemical resistance. But what does that do to the dielectric strength, having all those fillers in there? So it's making us explore things like that we wouldn't have had to do otherwise if these environments aren't pushing the envelope of performance.
Yeah.
So that's the fun part for us. As long as we've been doing this, there's new questions to be answered. So that's what we encourage people to bring to the table with us. And if we don't know the answers, we're going to work with the technical team at Chemours to chase this stuff down to get people positioned to be able to solve these problems.
Yeah, it's also a sign of a healthy, well-run company that we're doing continuing ed and we're doing continuing R&D. So again, I'd encourage anybody to get in touch with the team at Intech Services should you have any questions about anything that we talked about today, because it was a damn good talk, guys. Thank you very much.
Yeah, one of the things we're hearing over and over again, Nick, is this whole green initiative. Can't go green without Teflon.
Can't go green without Teflon.
There you go, man.
All right. You like that plug, Wolfie, coming in right there at the end?
Like the hammer.
Oh, my God. Well, this has been great. April's edition about dielectric strength, informative, educational, and fun as always. Mike, Chris, thank you so much.
Thank you, man.
All right. We're going to see you guys next month right here from Delaware on Deliver More. We'll see you next time.